Troubleshooting for hardware, networks, and software. About this course. Welcome to the Troubleshooting for Hardware, Networks, and Software course. In this course, you'll learn the troubleshooting techniques that IT professionals rely upon to resolve difficult issues. You'll explore established approaches to fixing hardware, networking, and software issues. You'll discover the steps to take when the answer is not immediately obvious. Learning objectives. After completing this course, you should be able to explain techniques for troubleshooting hardware issues. Explain patterns of exploration for troubleshooting network issues. Explain techniques for troubleshooting software issues. About this module. Module 1. Troubleshooting hardware. Introduction. In this module, you'll learn about troubleshooting methods and specific techniques for troubleshooting problems with hardware, including the following. Removing variables. Understanding expected device behavior by having a working knowledge of devices. Considering environmental and software changes that can impact the hardware. Using diagnostic tools to check hardware internally and externally. Replacing parts that have failed. Learning objectives. After completing this module, you should be able to list typical troubleshooting steps. Identify ways to remove variables when troubleshooting hardware. Explain the value of having a working knowledge of devices to help identify and verify issues. Describe the role and importance environment plays in how hardware functions. Identify common diagnostic tools for hardware. Recognize when to replace parts for hardware. Typical troubleshooting steps. 1. Understand the perceived problem. 2. Examine the symptoms. 3. Evaluate the problem. 4. Create a theory of most probable cause. 5. Develop an action plan. 6. Experiment with solutions. 7. Document your findings and solution. Generally, the troubleshooting methodology that you should apply in most situations includes the same, typical steps. Review and keep these steps in mind as you learn about techniques you can use to troubleshoot hardware, network, and software issues. Getting started with troubleshooting hardware. Most disciplines in technology are supported by specialists and generalists. Hardware is no exception. Every information technology, IT, support professional should know the fundamentals about troubleshooting hardware. As an IT support professional, you might choose to focus on a particular area like hardware and become a specialist in that area. Troubleshooting hardware. Troubleshooting hardware starts with basic troubleshooting. You'll observe symptoms and look for causes. When working with hardware, you need to take some safety precautions such as ensuring a device is unplugged or turned off, which might slow down your troubleshooting efforts. Applying fundamental troubleshooting techniques will make your job easier. Remove variables. Imagine you're an IT support professional assisting a user who complains that their printer doesn't work. Given this description, the problem might be anything. There are so many different variables. Perhaps the printer was unplugged, or the status screen failed. Maybe the power button is damaged, or the printer is out of paper. Regardless of the cause, the printer displays an error and status indicators light up. Removing variables example. You might investigate this problem in 4 basic steps. Step 1. Check the fundamentals. Hardware needs essentials. Most electronics need power. Tactfully ask the user to confirm that the device is plugged in or charged. Printers need paper and ink, and thumb drives need file space to operate properly. Verify with the user that the printer has what it needs to operate. Tip: you'll save time by working through a checklist of foundational operating items before you pursue complicated solutions to simple problems. Step 2. Check the information the device is giving you. You checked the printer for power and the basic items it needs, and it checked out fine. You then try the printer, and it works properly. You ask the user why they thought it wasn't working, and they say that the green light on the front was off. After some investigation, you learn that the LED light on the device failed, but all other functionality was working as expected. Sometimes lights fail, and small information screens go dark, but the device still works. For example, in the case of the printer, no fix is required to operate the device, and your job is to explain how to use the printer without the LED light. Step 3. Check individual components. If the basics and device information check out, but the device still isn't working, then it's time to go deeper. In devices that include many components, like a desktop computer, you can focus your investigation by ruling out items that don't seem to affect the symptoms you're seeing. For example, suppose the problem is that a desktop won't start up. You confirm that it's getting power. In this case, it's unlikely that the problem is the power supply. The system shows the power on self-test, post, screen. Also, the screen shows that the memory and central processing unit, CPU, are working, so you can rule out those components, too. Since the other major components are not showing issues, you can next narrow your focus to the hard disk. Step 4. Verify your theory. Once you've settled on what you suspect to be the problem, it's a good practice to verify your theory. This is especially true when the part or parts you need to replace are expensive and when replacing those parts is time-consuming. For example, one good way to verify is to use a spare part. Having a library of spare parts that you can use for testing comes in handy. If you swap out what you believe to be the bad part and the device works, then you've verified your suspicions. If swapping out the part doesn't fix the symptom, then it's time to look elsewhere. Summary. You followed the 4 steps to remove variables. You checked the fundamentals, checked the information the device was giving you, checked individual components, and verified your theory. Complete the following activity to apply the 4 steps to remove variables when troubleshooting a device. Imagine your job is in IT support at a small company. You're on a call with an employee who says their printer is not working. You're asking questions as you help them resolve the problem. How do you organize your questions to troubleshoot the problem? Understand expected device behavior. Many times, users will submit a support request because they misunderstand how a device is supposed to function. Public support pages and knowledge bases are evidence of this trend in simple misunderstandings and making assumptions. As an IT support professional, you need working knowledge of the devices you're supporting to avoid the same misunderstandings. Working knowledge of a device generally means you know how the device should operate under normal working conditions. Example, knowing how a Wi-Fi router works. Take a moment to explore the following device example. If you set up a Wi-Fi router in your home, you need a working knowledge about how to connect the device to the internet, how to connect devices, how fast the router should move data to and from the internet, and how to perform foundational troubleshooting. Here's the working knowledge you need about a router. A router does the following. Connects to the internet. Brings data from the internet to devices on the network. Sends data in packets. Has an assigned internet protocol, IP, address. Assigns IP addresses to devices on the network. Implements a firewall. Can include both a wired and wireless network. IP address. An Internet Protocol, IP, address is a unique identifier that helps the network router direct traffic to the correct device. Each device on a network has a unique IP address. When troubleshooting a router, be sure to check points such as connections, logs, and antivirus software. Know when to contact the Internet Service Provider, ISP, to check for issues. Be sure to test speed and connectivity at the node devices. And test whether a restart addresses symptoms. Here are some points to keep in mind when troubleshooting a router. Many routers support both wired and wireless connections. Connection problems can affect both types or one or the other. Understanding the type of problem the user is experiencing can help narrow troubleshooting. Routers have firmware and settings that you should check. Firmware updates can fix bugs, and router settings enable you to adjust the router to the specific network you're working on. Most routers have status lights. Most routers have a series of lights on the devices that provide insight into the router's status. Some of the lights can change color to indicate status. These status indicators can help you troubleshoot. Having working knowledge also means that if you need to go deeper into how the device works, you know how to do that. For example, a network router often has an application that you can use to do basic setup. But routers also have a more advanced interface that you can use to modify specific settings, troubleshoot problems, and extend the router's capabilities. While your working knowledge might not extend to the details of the interface, it should make you comfortable using the interface. Before digging into a hardware support problem, check that you understand how the device you're supporting is supposed to work. Here are some areas that you should know. What you should know. Know the device's basic functions. Sample questions you should be able to answer. What do certain buttons do? How is the screen supposed to operate? Does it print in color or black and white only? Does it have a power indicator? What types of audio cues does it make and when? What you should know. Know when the device is operating properly. Sample questions you should be able to answer. What does the device look like when it's on? What does the device sound like when it's on? What does the interface look and sound like when it's operating properly? What does the fan sound like? How does the keyboard operate? What does the touchpad do and not do? What you should know. Know the device's error conditions. Sample questions you should be able to answer. What happens when the device won't turn on? What are symptoms of a malfunctioning device? What can go wrong with these types of devices and why? What do visual or auditory indicators mean? What you should know. Know the device's simple fixes. Sample questions you should be able to answer. Does a restart fix certain problems? Does the device have dependencies on other devices? What does the manufacturer recommend for specific problems? Consider environmental and software changes. When you have a solid working knowledge of the device, it can help you rule out, or factor in, environmental and software changes. Technical devices are subject to the environment in which they operate. For computing devices, this means the physical environment as well as the software environment. When you have a working knowledge of the normal operation of a device, it can be easier to find environmental changes that impact that operation. This is part of establishing your theory. Example, what's impacting this printer? Imagine you get a support request indicating that a user's printer continually jams. You learn that the printer was working properly for months and just over the past week, it started jamming. You check the hardware and everything seems to be in working order. The rollers are clean and it has plenty of ink. You check to ensure there's no scraps of paper in the gears and the paper type hasn't changed. As you read over the manual, you learn that the printer has a normal operating temperature and humidity level. Over the last week, it has rained significantly in your area, and the humidity levels have been extremely high. You suspect this is causing the printer problems. You first move the printer to a drier area of the office, and the printer stops jamming. You purchase an inexpensive dehumidifier for the user's workstation, and this solves the problem. Many devices are designed to work under a range of conditions. Still, environmental impacts do and can happen regularly. Keeping a device's operating environment in mind should be a part of every support professional's methodology. Use diagnostic tools to troubleshoot hardware. Many hardware devices come with internal tools you can use to diagnose issues. These tools include log files that report operation of all aspects of the device. Some simpler devices will have a troubleshooting mode with a visual or auditory signal, like flashing lights or a number of beeps, that indicates the state of the device. Taking advantage of these tools can help remove the guesswork when you are troubleshooting hardware. Sometimes internal diagnostic tools aren't adequate. And some hardware devices don't include these tools. In these cases, you can try to use an external software package, or a hardware setup called a testing harness to troubleshoot an issue. A testing harness is a set of electronics that allow you to automate various scenarios the hardware supports. By using a testing harness, you have the capability to put the hardware in various situations and repeat them in a controlled way. Doing so can give you insight into a problem area. For example, a simple voltmeter can be used to test whether certain components of a hardware device are getting the power they're supposed to get. Virus scanners are also a type of diagnostic tool used to troubleshoot internal issues on a device. Running a virus scanner on a laptop that has slowed way down can help you confirm or rule out a suspected problem. Replace parts. When troubleshooting hardware, you might need to replace components that have failed. This typically is a last resort solution. Replace components only after you've exhausted other possibilities and concluded that a part has gone bad. Before deciding to replace a faulty part, ensure that you've isolated the proper component. In complex devices, this can be difficult. Swapping out a suspect part with a similar part that you know works can help rule out certain parts and focus on other ones. It also can prevent you from replacing components that are in working order. About this module. Module 2. Troubleshooting network connectivity. Introduction. In this module, you'll learn about challenges and problems that can affect networks. You'll examine specific techniques for understanding and evaluating network problems. You'll examine the difference between wireless and wired networks. And you'll explore ways to troubleshoot client devices and routers. Learning objectives. After completing this module, you should be able to compare and contrast wired and wireless networks. Identify common issues for wired and wireless networks. Identify areas to check to troubleshoot client devices connected to a network. Identify the hardware environment and settings to consider when troubleshooting home and enterprise networks. Recognize common wireless network challenges within an environment. Wireless and wired networks. Networks connect people and data through devices. Many variables can impact data transmission over a network. Some network connections are wireless and others are wired. Wireless networks use radio signals to transmit signals between two network nodes, sender and receiver devices, and are typically Wi-Fi, wireless fidelity, networks. Wired network connections use a cable to transmit data between nodes. It's important to keep in mind that networks can be a mix of both types of connections. Common issues for wired and wireless networks. When troubleshooting networks, you will find issues that are common to both connection types and issues that are distinct to each type. Remember, general troubleshooting methods that you should apply in most situations are useful for troubleshooting networking. Problems at the nodes. Sometimes network connections fail because either the sending device or the receiver is having an issue. For example, network cards on some computers require a driver, software that controls the hardware. If a driver has a bug, flaw in the code, then it can impact the ability of a wired network to send or receive data. Problems with a router. A router routes data, controls traffic, from one network to another. For example, data can go from the internet to your home network. If a router is having a problem, like an inability to communicate with the internet service provider, ISP, your home network won't be able to receive data from the internet. Problems with transmissions. Many things can impact network communication. Packet loss is an issue that causes part of the data stream to get lost. A bad connection, hardware issues, or interference, among other things, can cause packet loss. For wired networks, damaged or improper cabling can affect communications. For wireless networks, radio signal interference can cause unstable network traffic. Improper network settings. Improper transmission control protocol/internet protocol, TCP/IP, settings on a device can prevent it from connecting or cause slow or unstable connections. For example, if two devices are set to have the same TCP/IP address, the first one to connect to the router will get traffic, and the second device won't be able to connect. Now that you learned about common issues for wireless and wired networks, it's time to learn what you can do to troubleshoot networks, including rule out client devices, troubleshoot home and enterprise network hardware, consider environmental conditions for wireless networks, rule out client devices. A network connection sends data between two or more devices. When you encounter network problems, checking devices first can help you rule out common problems. A particular device might be having problems connecting to a network, or it might be experiencing a slow or unstable connection. Here are specific areas to check. Check the hardware. If you're troubleshooting a wired network problem, then first check to see if the network cable is firmly secured into the network adapter. Check also for a frayed wire or damaged connector. Check the network adapter. Review the device history and its settings. Check the history to see if software or drivers were updated recently. Rolling back a device driver can help you troubleshoot issues in these cases. Check the settings because many times, network adapters will get assigned an IP address from the router. The adapter has to be set to automatically get this address. An improper setting can prevent the router from properly assigning an IP address to the card. Check workplace software for conflicts. Many workplaces require the installation of management software on employee devices. This software ensures that company resources are safe by preventing certain pieces of software from being installed, monitoring network traffic, preventing access to certain websites, and other services. If the software has a bug or is incorrectly configured, it can interrupt network traffic. Check VPN settings. Virtual Private Network, VPN, software enables devices to access the company's network securely. When a device is connected to a corporate network through a VPN, specific network traffic is routed through the VPN software. Incorrect software settings or buggy software can interrupt network traffic or make it unstable. Check the firewall. Most devices have firewall software that prevents certain types of network attacks. The firewall can close ports, which are channels by which networks communicate with each other. If a firewall isn't configured properly, it can prevent valid traffic from getting through. Network connections involve many layers of software and hardware that enable them to work properly. Starting with the devices connected to the network will give you a foundation upon which to troubleshoot the problem. Troubleshoot home and enterprise network hardware. If you confirm the problem isn't with client devices, then investigate other network hardware. Focus first on the routers in the environment. Home networks typically have a single router and a modem. Corporate environments tend to be much more complex, especially in large enterprises. Troubleshooting home networks. Home networks generally connect to the Internet through an Internet Service Provider, ISP, like a cable or phone company or a dedicated Internet service. Here is a diagram of a network showing the relationship between a modem, a network router, and the devices they connect. The modem. ISPs require at least one piece of equipment to connect to their service, a modem. The modem is used to manage data that comes from the Internet. It translates that data into something the home network can use. Users can purchase their own modem in many cases, but ISPs also tend to provide that hardware for homes. The wireless router. The router is situated behind the modem. This means that the modem gets data from the Internet and sends the data to the router. The router manages getting the data from the modem to the devices on the network. Routers generally provide both wired and wireless network capabilities. Some ISPs provide a single piece of hardware that includes both the modem and router. When troubleshooting problems with home network hardware, you can use information provided by the devices themselves. For example, most modems have a series of lights on the front that indicate the connection status. If a light is on, that means the modem has a connection to the ISP. Some devices even have different colored lights to provide more detailed information. Firmware. Routers and modems run a special kind of program called firmware. Similar to software, Firmware usually resides on a special computer chip on the device and controls how the device operates. Most firmware has a user interface so you can change the device's settings. If users are having problems with their home network and the external status lights don't indicate a problem, then you might need to look at the settings on the modem or router's firmware. Between the two, support technicians generally spend more time in the router's firmware interface when troubleshooting problems. What can be set in a router's firmware is dependent on the manufacturer. Some routers enable users to set everything from how fast data flows over the network to whether and how often the router can restart itself. Others provide basic settings. For troubleshooting purposes, here are a few items most firmware programs enable that are worth a closer look. Dynamic Host Configuration Protocol, DHCP, settings. DHCP automatically assigns IP addresses to devices on the network. A common problem in the past was that the setting was not on by default. Most router manufacturers now enable the DHCP setting. Even so, check this setting. By default, manufacturers limit how many IP addresses a router can assign. This number typically is large enough for most households, but limits can be reached in certain circumstances. Wireless settings for radios. Wireless communication uses radios that operate at specific frequencies. Older technology used radios in the 2.4 GHz band. Newer technology uses the 5 GHz band. Each has their advantages and disadvantages. If a home user has the older technology, those devices might not be able to use the 5 GHz band. If a router has a 5 GHz band radio only or the 2.4 GHz radio gets turned off, those devices will not be able to connect. Wireless settings for passwords. If you've ever connected to a wireless network at a coffee shop or library, you will likely have had to enter a password. Wi-Fi networks use passwords to protect people from unauthorized access. Forgotten passwords can keep users from accessing the router. Poor passwords can impact the security of the network. The Wi-Fi password is distinct from the password you use to access the router's firmware. Troubleshooting enterprise networks. Many of the hardware and troubleshooting techniques you learned about for home networks apply to enterprise networks. Enterprise networks have routers that have firmware and DHCP settings that can be adjusted. However, corporate routers tend to be more complex than home routers, and corporate network topologies, configurations, typically involve more pieces of hardware than home network topologies. Network topology. Network topology describes the arrangement of network devices and connections. Topology is like a roadmap showing the routes that the traffic might take from starting points to destination points. Physical topology refers to the arrangement of the devices and connections. Logical topology refers to the concept of how and why the network is arranged a particular way. Troubleshooting enterprise networks involves a broad understanding of all the hardware in the topology and how client devices communicate over this hardware. The following two diagrams show the difference between a home network topology and the arrangement of the enterprise network topology. Home networks typically have more simplified network arrangements, while enterprise network topologies are more complex and include more pieces of hardware. In the diagrams, the home network has 5 devices connected to one router, and the enterprise network has 9 devices connected to 3 routers. What types of network devices might you encounter in a corporate environment? User devices. Each employee might have a wired desktop or a wireless laptop and a mobile device. The workspace also has network printers, voice over IP, VoIP, phones that use the Internet for calls, servers, and some Internet of Things, IoT, devices like network-connected light bulbs and power outlets. Routing devices. To make all this work, you might need to use hardware like hubs and switches. These devices help connect multiple devices to a single router. Hubs and switches just manage network traffic for multiple devices to the router. The topology still needs a router to route traffic between devices and the Internet. Server devices. You might also need to use a software and hardware combination called a gateway. Gateways act as the translator for different types of networks. Gateways are common at enterprises that have various locations and whose networks use a variety of protocols. Protocol. A protocol is a type of language for how network devices communicate. For example, the Internet uses the Hypertext Transfer Protocol or HTTP. While home and enterprise networks have many similarities, you need to understand their differences to troubleshoot each type. Can you identify each troubleshooting activity according to the type of network it applies to? Consider environmental conditions for wireless networks. Not so long ago, cars lacked the technology for satellite radio or the ability to connect to mobile devices to stream music or podcasts. Travelers often used AM and FM radio to listen to music and talk radio, a precursor to podcasts. AM and FM signals can have a hard time finding their way through tunnels on the road, so the sound might turn to static. Because wireless networks use radio signals to communicate, they are subject to particular environmental challenges. Radio interference is one challenge. Today's wireless routers are very good at accommodating radio interference, but something like a microwave oven can still significantly interfere with the radios. Troubleshooting environmental factors for wireless networks. As an IT support professional, you need to take environmental factors into consideration. Here are a couple of considerations to keep in mind. Think about the physical environment. Wireless radio signals are also impacted by corners, walls, and even the material in the walls. Distance from the router impacts how strong a signal is. For example, the signal from a router located in a bedroom might not reach the backyard. Router manufacturers have tried to address these issues by creating routers that use satellites to amplify the signal. You should be aware that the location of the wireless router can impact how fast and stable the network connection is. Think about signal interference. Wi-Fi technology continues to improve, and many of the problems that affected early versions of wireless routers manufacturers have been solved. But, because Wi-Fi uses radio signals, other problems might show up. You must consider how to design wireless network topologies and be aware of ways to solve network problems that are particular to wireless networks. For example, if people in an apartment complex all have their own wireless routers, the signals might interfere with one another. The Wi-Fi specification describes the maximum signal strength for wireless radios and how to use channels to modify on what frequency the signals travel. This helps address interference issues. Even so, interference in high-density environments can be a problem. You should know how to look for and properly set channel frequency to solve certain types of problems. About this module. Module 3. Troubleshooting software. Introduction. In this module, you'll learn the difference between troubleshooting software and debugging it. You'll gain insight into the importance of understanding how a software package is supposed to work. You'll examine ways to rule out hardware when troubleshooting. And, you'll learn the difference between troubleshooting software based on output only and by looking at the code. Learning objectives. After completing this module, you should be able to compare and contrast troubleshooting and debugging software. Identify possible results when using a working knowledge of software to troubleshoot. Explain a process for ruling out hardware issues when troubleshooting software. Compare and contrast functional and structural troubleshooting. Recognize how software can help troubleshoot software. Troubleshooting versus debugging. When it comes to troubleshooting software, you might think of software developers as the people to go to for help. Although they might not develop code, IT support professionals spend a significant amount of time addressing software issues. As an IT support professional, you will often help users with software-related problems such as bugs. Bugs are flaws in code that can cause crashes and require workarounds and configuration changes. An important part of your job will be to provide continual support for system software packages. IT support professionals need to maintain software to keep servers running and networks performing at their peak. When you troubleshoot a symptom, you focus on one part of a bigger problem. When you troubleshoot a cause, you investigate the root of the problem. You notice as you've been doing laundry over the past few weeks, that the whites come out with a yellow tint. You troubleshoot the problem by searching the internet and draw a conclusion that you need to add more bleach when you wash whites. This solves the problem but doesn't address the issue that caused the problem. You want to know the cause so that you don't continually have to add more bleach, so you call a repair person to examine the washer. Their analysis involves asking you a series of questions. How long have you had the washing machine? When did you last have the washing machine maintained? How long have the whites been coming out yellowish? The repair person takes the back off of the machine, examines the filter, and discovers that it is past the useful lifespan. They recommend you replace it to improve the cleaning performance of the machine. This fix addresses the cause of the problem. As you reflect on the situation, you realize you were troubleshooting and attempting to address the symptoms. The repair person was investigating to find the cause. Both types of troubleshooting are important in different contexts. When you are unable to investigate causes, dealing with symptoms may be your only course of action to get users unblocked. When you can identify root causes, this is preferable. What are ways you can address problems with software? Find workarounds. When troubleshooting a software problem, you look at symptoms and try to find ways to get the software to work without solving the root problem. For example, suppose a diagramming program you support has a bug that prevents users from saving files to a specific file format. You find a workaround that enables the users to save to a different file format and then convert the file after it's been saved. Read the free manual. In some cases, like the expert mechanic, you'll also need to use documentation from manufacturers as well as the best resource, the internet, to investigate root causes. If you have access to the code, you can go even deeper and find why a symptom is occurring. Troubleshooting software. You'll explore software manuals and the web to try to figure out what the problem is. You might dig into settings and try some things to sort out the problem. Ultimately, your goal is to make the software work again so a user can get back to doing what they need to do. Debugging software. Developers try to find and fix root causes of flaws in program code. Debugging happens at the source code level. IT professionals generally don't debug. However, as troubleshooters, they can get software to function again and work with software developers to ensure that the root problems get fixed. Troubleshooting and debugging are both ways to fix problems. Troubleshooting is most often something that you do to get a product that you were using to work again. Debugging can also get a product to work again but is something that software developers do while they are building and testing code before it is released to production. You can troubleshoot and not fix flaws in the code. If you use a flea trap and rid your house of insects, that's troubleshooting. If you are able to find the nest where the insects are coming from and treat the area to repel the insects, that's debugging. Now that you learned about debugging versus troubleshooting software, it's time to learn more about techniques to troubleshoot software issues, including understanding the expected behavior of software, ruling out hardware issues, using functional and structural testing to investigate the problem, options for using software to troubleshoot software, understand expected behavior. When troubleshooting software, you need to have a working knowledge of how the software package was designed to work. Then you can quickly solve many apparent issues that users might have if the issues are based on mismatched expectations. The user might expect the software to work differently than the way it actually works. Explore these ways you can help users by knowing the software. Find bugs. You more easily can find bugs. For example, suppose a user creates a support ticket that states that they can't create a bibliography with their word processor. You know that this is a feature of this particular word processor and users were able to create bibliographies in the past. You suspect that a recent update introduced a bug, verify it, and inform the user. Find workarounds. You can be aware of workarounds. Many software packages have more than one way to do something. For example, a spreadsheet program might enable users to enter a formula using a keystroke for one or more menu items. If the software has a bug that causes the keystroke function to fail, providing a menu-based workaround can keep your users productive. Find alternative software. You can recommend alternative software. Suppose you're supporting a company that uses cloud-based software. One of the programs in the software package is a diagramming tool. A user would like to create a three-dimensional model of one of the diagrams they have created, but you're aware that the cloud software doesn't support this feature. You can recommend an alternative or a desktop version of the same software that might have the feature they need. Think about it. Have you ever used a software package and wondered if the developers of the software actually use it themselves? Sometimes a key feature might be missing, or the user interface is difficult to navigate. You can learn the details of the software you're supporting best by being a user yourself. It's not always possible to be a deep user of every software package you support. But doing some test projects that mirror what your users work on will go a long way in helping you better support them. Rule out hardware. One step in troubleshooting software is to rule out hardware issues. Example, is software really the issue? Suppose a user submits a support ticket stating that their word processor is repeating keys. They press certain keys like C, N, and U, and instead of getting one letter, they get three of the same letter. For example, new displays as N and new. How would you proceed to troubleshoot this problem? Initial assumption. Initially, you might think this is a software issue. If you took your assumption at face value, you might spend time trying to determine if the software has a bug or if there's a setting that is causing certain letters to repeat. More research. After some research and talking with the user, you learn that some of those keys also repeat in other applications. This might be a problem with the operating system, you think, while you are still focusing on software. A discovery. After more research, you learn that the keyboards on new laptops produced by the manufacturer have a flaw, and a recall has been issued. You provide the user with an external keyboard to use while you work on getting the laptop replaced. Ruling out hardware. If you're seeing a symptom in a software package, some simple steps can help you rule out hardware as the cause. The steps in the following flow chart can be used as an indicator, but not as an exhaustive list. The flowchart asks a series of questions and answers to direct you to software or hardware issues depending on the answer. 1. First, does the problem happen in other applications? If so, it might not be software dependent and might point to a hardware issue. 2. Second, can you replicate the problem with the same software on different hardware? If so, it might be a bug or setting in the software, and if not, it might be a hardware issue. 3. Third, does using different hardware address the issue? If it's relatively simple to change out the hardware, like using a different keyboard or mouse to solve the problem, it points to hardware. If not, it might be a software problem. 4. Finally, if you use a similar software package, does the issue go away? For example, if you're using a word processor and try a basic text editor and the problem doesn't show up, it might be the software. Otherwise, it might point to hardware. Use functional and structural troubleshooting. When would you use functional and structural tests while troubleshooting? In a functional test, you use the input and output of the system to evaluate its performance and how well it works. In a structural test, you examine how something works and how its parts work together so it can do what it's supposed to do. If you were functionally testing a blender, you might see if it can blend nuts, ice, and vegetables adequately. You would be concerned not with how it does what it does but with how well it does those jobs. If you were structurally testing a blender, you would take it apart to see how the motor turns the blade, to look at the material that makes up the blade to ensure it can blend various materials. You would seek to understand how all the components work together to make the blender work. Troubleshooting software with functional and structural testing. When you functionally troubleshoot software, you use the interfaces the software gives you to put in data and get a result back. For example, if you're trying to figure out why a spreadsheet formula doesn't give you the result you expect, you enter different data to try to determine if there's a bug or if you misunderstand how the formula is supposed to work. When you structurally troubleshoot software, you need access to the code. For example, to troubleshoot the spreadsheet formula structurally, you use a predefined set of parameters that will execute the formula in a variety of situations. By looking at the code, you learn that the formula requires the numbers you enter to be in a specific format. You're unsure what the format is, you don't have access to the formatting code, so you try numbers with a variety of formats to discover which ones the formula can support. What's the difference between these two methods of testing? When you structurally troubleshoot, you have access to the code, which enables you to have knowledge of how it's supposed to behave. You're examining how the code actually processes data and using that knowledge to refine your tests. When you functionally troubleshoot, you are examining inputs and outputs only. Both types of troubleshooting can be useful. Many times, IT professionals don't have access to the code, so they can only functionally troubleshoot. Structural troubleshooting can help in situations where the software was developed by the company or is open source code. Using software to troubleshoot software. When you need to learn something new, like how to fix a piece of furniture, you might consult the internet. In this case, you're using technology to help you get the information you need. If you have a friend who works in that area, say a woodworker, you might choose to ask them instead. In this situation, you're working with another human to get the information you need. There are many software packages that you can use to troubleshoot software. Like a helpful friend, these software programs are designed to give you helpful information about other software programs. What are some ways you can troubleshoot software issues? Examine the lights and sounds. Some hardware devices have indicators like lights or sounds that tell you there is something is wrong with the software. These indicators tend to be broad. They tell you that something is wrong, but not exactly what is wrong. Look at the log files. Many operating systems enable you to create log files. Log files are created by software. They can be used to troubleshoot hardware and software. The files will track every important event happening on the device. By looking at these logs, you might be able to spot events that are causing the symptoms you're troubleshooting. Explore analytic software. Software that gives you information about Central Processing Unit, CPU, and memory usage also can be very helpful. For example, if a computer is running very slowly, this software can tell you if some other software is using too much of the CPU's power or too much memory. Monitoring applications. Many organizations either build or buy special software that monitors mission-critical software to keep their businesses running. Cloud-based software packages include monitoring software that will alert IT professionals when something appears to be operating abnormally. They also include analytic tools that you can run to ensure your cloud software is running as you expect. IT professionals need to be aware of and use these software tools. You also should assemble your software toolkit that can help you troubleshoot software. What do you think? Think about techniques you learned for troubleshooting software. If you encountered a software issue, how would you begin troubleshooting? Enter your response in the provided text box. When you are finished, select Done. Writing an answer is a good way to process your thoughts. These answers are for your use only. You have the option to download your response and save it. It will not be saved in the text box when you move on in the course. Evaluate your thinking. Does your answer account for the following? When testing software, be sure to work through the basics. Do you understand how the software is supposed to work and can verify the issue is not a part of the software's expected behavior? Were you able to rule out hardware as a potential source for the problem? Were you able to replicate the issue on other devices or in other software? After you've explored these areas, functionally testing the software might be a good next step. By functionally testing the software, you can evaluate the boundaries of the issue, under what conditions the issue appears, and that will continue to build a foundation for addressing the problem. You've come so far and learned so much. You have discovered methods to solve support problems when the solution is not obvious. You learned about techniques that IT support professionals use to troubleshoot hardware, network, and software issues. Now that you've completed this course, you should be able to explain techniques for troubleshooting hardware issues. Explain patterns of exploration for troubleshooting network issues. Explain techniques for troubleshooting software issues. Key points to remember. Troubleshooting hardware. 1. Troubleshooting hardware starts with basic troubleshooting, where you observe symptoms and look for causes. 2. Working through a checklist of fundamental operating items before you pursue complicated solutions can save you time. 3. Focus your troubleshooting by ruling out items that don't seem to impact the symptoms you're seeing. 4. Working knowledge of a device generally means you know how the device should operate under normal working conditions. 5. When you have a working knowledge of the normal operation of a device, it can be easier to find environmental changes that impact that operation. 6. Using diagnostic tools can help remove the guesswork when you are troubleshooting hardware. 7. Replacing parts is generally a last resort solution for troubleshooting hardware. Troubleshooting networks. 1. When troubleshooting wired and wireless networks, you'll find issues that are common to both connection types and issues that are distinct to each type. 2. When you have network problems, checking devices first can help you rule out common problems. 3. When solving problems with network hardware, you can use information provided by the devices themselves. 4. Troubleshooting enterprise networks involves a broad understanding of all the hardware in the topology and how client devices communicate over this hardware. 5. Because wireless networks use radio signals to communicate, they are subject to particular environmental challenges. Troubleshooting software. 1. Debugging can get a product to work again, but is also something that software developers do while they are building and testing product code before it is released to production. 2. When troubleshooting software, you need to have a working knowledge of how the software was designed to work. 3. If you see a symptom in software, rule out hardware as the cause. 4. In a functional test, you use the input and output of the system to evaluate its performance. 5. When you functionally troubleshoot software, you use the interfaces the software gives you to put in data and get a result back. 6. In a structural test, you examine how a thing does what it does. 7. When you structurally troubleshoot software, you have access to the code. 8. When troubleshooting software, you can use software programs designed to give you helpful information about other software programs.